So far, everything that we've learned about trigonometry, we've been working in right angle triangles, right? And we know that opposite our right angle is our hypotenuse, and if this here is our reference angle, then we know this side here is known as opposite, and then this here would be known as adjacent, right? And then from there, we moved on to the three trig ratios that you all already have knowledge on, where sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. You need to know it in this format over here, even though in class I told you guys we don't like using this format as much for all the other trig ratios and things like that. But for this section here, because we're now taking our triangles and no longer have them on Cartesian planes and we're putting them in real world situations, you need to know it in this format. Most learners learn it like this. That's how most learners learn it, so you can remember it like that. But the problem now exists, what happens if I no longer have a right angle triangle like this triangle over here? So we have two rules which we can use, the sine rule and the cos rule, which you can use to solve for the unknown sides or the unknown angles. And you can pick and choose which ones you want to use. In this video, I'm just going to give you a recap of everything that we did in class in case you missed it. The sine rule is talking about ratios between each of the angles and its corresponding side in correlation to the other sides, right? So you already know this, it's already written in your book. We're taking sine of this angle. If this is labeled as capital A, then opposite it would be small letter A. If this is capital B, opposite it would be small letter B, and if this is capital C, small letter C. You can also label this here as BC, CA, etc. It's perfectly acceptable, right? So this here is the sine rule. I'm going to do an example just to remind you. When would you use these things? You'd use the sine rule in most cases if you're given two sides. So for example, if I give you information about this side and I give you information about this side, but I also give you information about one of the opposite angles to it, then you would use the sine rule. If I gave you two angles, so let's say I gave you this angle and this angle, and then I gave you information about one of them opposite it, so for example this one, then you would use the sine rule. I'm also going to talk about the ambiguous case, which is, well, we'll talk about that a little later. Right? We then move on to the cos rule. I'm using the same diagram over here as a reference, and this one here says, you can see it looks very familiar to Pythagoras. I'm going to write out the proof for you as well. This one says that a squared, so a squared, which is the side here squared, is equal to b squared, the side squared, plus c squared, plus the included angle over here, right? Oh, sorry, I had it the other way around. This angle over here. And you can use them for each one of them. Now, I've written it with A, B, and C because of this triangle, but you can use it for any other triangle. It doesn't have to always say A, B, and C. Another thing you also know, you don't always have to write out the rule. You can literally just jump into the substitution part. We don't give marks for the rule. We give you the marks for the substitution. And when would we need to use the cos rule as opposed to using the sine rule is when you're given two sides and an included angle and you need to find the opposite side, or if you're given all three sides and you need to find out one of the angles. If you're given something like that, you'd have to substitute it into here, and then you're going to press right at the end after you've solved shift cos, and then you'd find whatever angle you need to. Okay. Here's an example where we're going to use the sine rule just for recap purposes. Okay, so this question over here says that we need to solve for this unknown side over here. What I like to do first is label them with the small letters. So if this is capital B, this side here is basically small letter B, this side here is small letter A, and this side here is small letter C. As you can see, I have no information about C, so I'm not even going to look at that side. I can also see that I have information about two angles and one of the sides that are opposite, right? So they correspond, opposite each other. So I know you always start with whatever is unknown, right? It makes it easier when you set up your equation and you need to solve. So I'm basically looking for the sine over here. So I'm going to say small letter b over sine of big letter B, which is this angle here, equals, and what I have information about, so small letter a over sine of big letter A, right? As I was saying, you don't have to write this down. I'm writing it just because it's a recap for you guys. B is what I'm looking for, which is x over sine B, so sine of 45 degrees, which is equal to A2 over cos, sine of 30 degrees. And now we're just solving. We've set up an equation. We're now just solving for the unknown. So x equals 2 multiplied by sine 45 degrees. And you can plug this in onto your calculator or just read the instructions. If it says use special angles, then you're going to use your special angles. Quick recap on special angles because a few people made mistakes with that in paper. Okay, this is 0, 30, 45. Okay. Okay, if I wanted sine of 45 degrees, you go to the 45. We know sine is y over r. R is 2. So root 2 over 2 multiplied by the 2 that was over here. Over sine of 30, we know it's y over r. So again, root 1, which is 1 over 2. This 2 and this 2 cancel. I'm left with 2 over half, which is equal to 2 root 2. Is a different type of question where we're given the cos rule, okay? The cos rule, as you can see, it's two sides and an included angle. If this was a sine rule, they would have given us information about one of the opposite sides, right? What we're going to do over here, this was the unknown that I needed to find. I'm looking for this. I told you first step that I like to use is first labeling it. So this here would be D and this here would be C. What I'm looking for is always going to be the subject of the formula. So I'm going to start here. B squared equals, and it doesn't matter which one of them you put first. I'm going to go C squared plus D squared minus 2CD cos of the included angle, which in this case is angle B. And you'll notice that this usually corresponds with the small letter that you've put over there. Right? These are the easy questions. We're going to move to the far more complicated ones where they're given real life word problems. Okay, substitution. This here is x squared. Again, you don't need this step. C10 plus 12 squared minus 2 times 10. So of angle 54 degrees, and then you just punch this whole thing in onto your calculator as is and find an answer. Please don't forget that this answer that you find in is squared. So when you find the final answer, you have to square root whatever this is. Don't forget that don't round off in between steps. So for example, if you got this answer over here, please don't on your calculator do this. You're not going to get to the same answer. Okay, in this particular case here it worked out, but in all cases it doesn't work like that. So please don't round off in between steps. Another thing, if the question has given you that this is meters, please don't forget to fill in the units. If it hasn't given, then it's perfectly fine to just leave your answer as is. And lastly, we need to learn about the area rule. If you were given a normal right angle triangle, like we've been working from like grade 6 and 7, we know that any right angle triangle, even not a right angle triangle, when they gave you a triangle, they usually gave you the perpendicular height to it. Like for example, this triangle, they give you the perpendicular height over here, and then you using this formula known as half base times perpendicular height. Then what happens if you don't have the perpendicular height, but you have any triangle? You would then use this rule over here. Okay, and again, I'm using the same triangle ABC, so this is the rule. I'm going to use this, what we worked out over here, and see if we can work out the area of this triangle. So we know, and just sketch this again, 54, 10, 12. Okay, this is our triangle. If I wanted to work out the area, it would be, you don't have to write down the formula, you can just substitute. So half Okay, you're going to take this side, multiply by that side. So 12 multiplied by 10 multiplied by sine of the included angle. Now, how are you going to remember that it's an included angle? Think of it like this. There's the alphabet A for area. I need this, I need information about this, and I need the included angle. That's how you're going to remember it. And then we just type it in on the calculator and get our answer. And that is our answer. Again, if there's units given, you write down the units. Please, if it isn't, write it down as units squared, because we check that you know that area is actually square units. And that's all that there is that you need to know about the basics. I'm going to do a separate video for ambiguous case and a separate video with the proofs.